Okay, so if you've worked along with this about derivatives, one of the things that have come up is this idea of maximum and minimum. And so we have just some sort of generic function here. I don't know what was used to create it. And what we want to know is, how do I know is when is there a maximum or minimum? Well, if we look at this function real quick, we know where the maximum are. They're there at this peak, they're down there, they're here where it turns around again. So we can see them easily, but what quality do they have that we can use to determine those sorts of things? And so we think about this idea of derivative, that dy, maybe I should just call that dy instead of f of x, but dy dx is the change in y over the change in x as we get to really small, right? So what happens at a maximum? Well, at a maximum, that change is a flat line. It's leveled off. It's not going up anymore, it's not going down anymore. It's leveled off. So what does that mean? So added max or min that the derivative of x is going to equal 0. That the first derivative of whatever it is going to be 0. In other words, it's leveled off. But then, how do I know if it's a max or min? Without graph, so without that, how do I know if it's a maximum or a minimum? The answer is the second derivative. The second derivative is, we may notate this way, d squared y over dx squared, just noting that we've taken the derivative twice, or y double prime. It's also equal to, the way to think about, another way to think about that is d dx of the first derivative. So it's the derivative of the first derivative, it's the second derivative. What does that tell us? Well, the second derivative determines direction of curve. And that's a little bit abstract to talk about, but when we think about it, if the derivative tells us whether the function is increasing or decreasing. So in other words, if the derivative of x is greater than 0, f of x is increasing. If the derivative of x is less than 0, it's decreasing. And it has a negative slope, right? So, negative slope, it's going down. So the derivative tells us what's happening with the function. Well, the second derivative is that. So it tells us how quickly, it tells us how the derivative is changing. So the key thing is, if we think in terms of the second derivative, that if it's the derivative of the first derivative, when the second derivative is greater than 0, that means our function, our derivative is increasing. And if we think of the derivative as the slope, that the slope is getting bigger. So a constant slope, of course, it can be positive or negative or whatever. But whatever case, it's going up. It's getting bigger. So what that tells us is that either it's positive and it's going to start going up quicker, or it's negative and it's going to start getting towards positive. So what that basically tells us for the function is it's curved upward for the second derivative is greater than 0. By the same thought process, if we think of the second derivative being less than 0, that means the first derivative is decreasing. So another way to think of that is that the slope is getting smaller, or that if it was positive, it's going to start leveling out to 0, and if it's negative, it's going to get a lot more negative. So when we look at that, the curve faces down. So what can that tell us in terms of about maximum and minimums are that what we know is that if we know the derivative is equal to 0, then we have a max or a min. So then if we look at the second derivative, if we're at a minimum and the second derivative is greater than 0 at that point, that's this area, it's curved up, so we must be at a minimum point because we're facing up as we go. If we're at a spot where the derivative is equal to 0, we know we're at one of these maximums or minimums, and the second derivative is less than 0, then we're at a max because it's curved down, so it must be we're at the top of the peak. So we can use those two things to help us determine when we find a maximum or a minimum, whether it's a max or a minimum. And I also refer to these as local max and local minimums. If we think back to our graph, each one of these, the derivative is 0, and we'll find the second derivative being negative there and positive here. What that means is that we have a curve and a local there. That locally, it stops and turns around. There are some points that if we want to know the absolute maximum minimum, we'd have to check each one of those points and see which one's the highest and which ones are the lowest among our minimums and among our maximums. So that takes a little bit more work. Which brings up the natural question. We talked about what's going on when the second derivative is greater than 0 and when the second derivative is less than 0, the types of curves that are going. What about when it's actually equal to 0? Well, then that's what we call an inflection point. And this is simply a place where the direction of the curve changes. And this is not necessarily a max or min. So an example of what that might look like would be if we had a function that looks something like this, where this is our graph. Maybe a cubic type function. Here we would see f prime of x equals 0, and then we would also find that f double prime x equals 0, because basically at that point we've changed. It used to be curved facing up, now it's curved facing down. So the curve changed, that's an inflection point. We get the derivative equal to 0, but it ends up not actually being a max or a min.